everyone, welcome back to my channel Cat by Nagendra. So in this video we are going to see about next mates called mechanical mates. So in before tutorials we have seen about standard mates, again advanced mates. Now we are going to see this mechanical mates. For that let me directly enter into here assembly design. Let's say okay. Now I don't want to insert any component here. So if you are going here with mechanical mates, first mate will be having here cam. So already we know what is meant by cam is. So usually cams will be seen in like engines. So where we will be having the fuel and air mixture, that fuel will be coming through that inlets. There because of this cams only that valves will operate, and because of that only fuel and air mixture will enter into engine. Later it will go for combustion process. So that made here directly we are having here as cam made. For that already I have created cam parts, so just I will insert the components and I'll show you how this cam made will work in SolidWorks. For that just I'll go here with insert components. So before only I have created these parts and I have saved it here. So just I'll go here with the cam and follower. So this is a follower, just I'll open that. If you want to change direction, let me change here with reference to y direction and I'll keep it here. So first component is fixed. Then again I'll go here with insert component. I'll call this cam also. Just I'll say open. I'll rotate this also and I'll keep it somewhere here like this. So now if I go here with the mate, then I'll close the standard mates. We are going here with mechanical mates. So under mechanical mates, first one we are having here cam. So cam is nothing but with reference to this follower point, this cam should rotate automatically. Like if we are able to move this cam in linear motion, automatically it should perform rotary motion also. So that we will see now. Again, next one we are having here slot mate. So slot mate is nothing but in advanced mates we have seen this path mate. Path mate is nothing but with reference to any point along with the curvature, that point will move only with reference to that existing curvature, but it won't move any other side. Same similar to that. Here in mechanical mates we are having here slot mate. Slot mate is nothing but, let's say for example this round part is there. This one it should move only with reference to this length. Along with that, like it should travel only with this measurements. So it should not go up or it should not go down. So in such cases we can use here slot mate directly. So first let me apply here slot mate between this cylinder. It should travel with reference to this. Let's say okay. Now properly it will move with reference to that only. Up to that length, how much length we are having here this slot, only that much length it will travel in linear direction. Then this face I need to attach with this face. I'll make it here standard mates called coincident, that already we know. Just we need to attach that with reference to that. Then now if I try to move this, you can see only it is moving up and down direction, and this tip point also going beyond that follower part like this. Let me keep it here somewhere like this. Then now we'll go here with this cam mate. To apply this cam mate, we need here cam path and cam follower. Cam path means this point with reference to which path it should travel. So we know that this should operate with reference to this face, this cam outer face. Then cam follower. So this is the follower. So to select this cam follower, let me show here with points. Already I have created this point. Point I need to select. If I click here, automatically that point will attach to this cam path, and let's say okay. Now just I'll make it isometric. I am going to make it only here linear motion, you can see here, but automatically we are getting here rotary motion also. I am not rotating this component, just I am moving up and down direction, but we are able to get rotary motion also along with that. So for better explanation, you can observe here. Here just I'll move only top and bottom, but along with that automatically we will get here rotation also like this. So just we can move this and we can see the movement. Like this cam will be operated in engine assembly like this. I hope you have understood about this cam. Usually we won't use all this in depth, but wherever we required while making motion study or any simulations, there we'll use these mechanical mates. So that is about cam and slot mate. I hope you have understood about these two. Then next mate we are having here hinge mate. Hinge mate is nothing but, let's say for example, in our homes we will be having doors. So for the door we will be having, like if you want to close or if you want to open the door, that mechanism will be there with inclination. So that part we call it as hinge. So let me show you how it will work in SolidWorks. So for that, let me enter into here new assembly design. Same for hinge mate also, I have created already some two parts. I'll go here with hinge. So this is the hinge. Just I am taking this part like this. Then same part we need one more. So just you can hold control, drag that part, you will get one more. So let me rotate to make it proper orientation like this. It should get assembled like this. Let's say okay. Now directly we can go here with mechanical mates. Directly we can go here with hinge mate. Here concentric selections we need to do. So concentric is nothing but usually we'll use for circular profiles. So this one, it should be concentric to this, any one you can select. Then coincident selection, which one to which one we need link here. So here this face, it should get attached with this face. I'll select this properly, it will align to that, and let's say now just if I try to rotate this with reference to that only, it will operate. Like for this door side, this will be fixed and this will be attached to door. You can open or you can close the door like this. And here also we can give minimum and maximum angles. Why? Because maximum we can open this 180 degrees, minimum we can close, like how much we want we can do that. So for that also we are able to give here minimum and maximum angle, which are available for us in advanced mates as we have discussed earlier. So just I'll go for mate. It means if I want to rotate this, this is able to rotate in 360 degrees, but I don't want like that. Minimum it should come close to that some 3 degrees or 5 degrees. Maximum it should go some 60 degrees like that. So we need to set that. So just I'll go here with standard mates. Angle mate we want between this face to this face. Now minimum angle, let's say for example I need some 5 degrees. Maximum angle it should go 60 degrees. Beyond that it should not go. So this is the current angle. I'll make it here 5 degrees only, and let's say okay. Now just let me show you here. If I try to close this, it won't close. Why? Because minimum angle we have given 5 degrees. Then again if I try to open, maximum it can move only up to 60 degrees. Beyond that it won't move. Why? Because maximum angle we have given 60 degrees only. So like that we can operate this minimum and maximum angles by using advanced mates with mechanical mates like this. So I hope you have got clarity on this hinge mate, how to use this. Then next in mechanical mates, next we are having here gear mate. So gear mate is nothing but we are able to call two gears, and if we rotate a single gear, automatically the driven gear also should be rotated. Let's say for example we are having one driver gear and the driven gear. So if we are able to rotate, or if we are going to rotate this drive gear, automatically driven also should be rotated. So that we will see now. So for that directly I'll go for assembly design. Here no need to create our own gears. Why? Because standard gears will be available in, like in built SolidWorks only. So that will be available here. So we can go here with design library. So in design library, I'll go here with toolbox. Click on toolbox. Then let's click on this add in now. Here we will be having different type of standards like ANSI standards, ISO standards, IS standards, DIN standards, whatever we want we can take. But maximum conditions will go here with ISO standards, like International Standardization of Organization. Just I'll open that by double clicking on that. Under that, again we are having bearings, bolts and screws, keys, nuts, o-rings, pins, different type of things are there with standard sizes. Now what we want, we needed here gears. So gears will come under this power transmission. Just I will double click this to open that. Then again under power transmission, we are having chain wheels and gears. We need gears. Again in gears we are having helical gear, internal spur gear, rack gear, like rack, spur gear, different type of gears are available. Now let me take here with spur gear. So helical means it will be with inclination. Better we can go for spur gear. Just you can drag and drop here. Then we are able to select the size. Just you can see here. This is the module number. Like this is a module size number. How much we want we can take. Let me keep it here 20 itself. Then how many teeth we want here, that we are able to manage. Let's say for example I need here 20 teeth like this. Then next pressure angle we want, we can change that. Again face width how much we want. Width I need, let's say for example I'll take some 40. Then nominal shaft diameter, here this shaft diameter how much we want, which style we want. You can see here B type is there, like extra we are getting here. If I change to C, we are getting again in different way, like both sides we are getting this. So let me make it here type A only. We don't want any external thing. Then nominal shaft diameter we are able to select. I'll make it some 100, the shaft diameter. Then show teeth, how many teeth you want to show. So let's again keyway also we are able to select rectangular cutout here to make it in, or to insert a key, or both we can get. So we don't want anything, I will keep it none, and let's say same like that one more also we will get. So in this condition we need two gears. Why? Because one is driven gear, one should be drive gear. So let me keep somewhere here like this. Again multiple it will be coming. How many we want we can insert. Later just we can close this. Let me make it isometric. Now first gear is fixed. So what I'll do here, so for fixed one, I'll make it here float. So it will be freely moving now. This one also will be moving freely. Now one drive gear should be fixed properly, but rotation should be present. For that, I'll go visibility and I'll show here view temporary axis. So this axis will be shown. Now to make this properly fixed at particular point, already we know for assembly we are having origin point. So just directly I'll go with the mate. I will make mate relation between this axis to, I'll open this, I'll make relation with reference to origin point like this. Let's say okay. Now it won't move any other direction, but in this way it will be moving. So here again what I'll do, this face I'll select this any one of the plane to make it proper relation. Let me make it here with the right plane, coincident, and let's say okay. Now this gear won't move anywhere, but rotation should be there. Like this, it will be able to rotate. So with reference to that, like if I rotate this gear, automatically this driven gear also should be rotated. For that, what I'll do, again I'll make here relation between this face, it should be straight to this face. So I'll make it coincident between face to face like this. Let's say okay. Let me drag that out like this. Then just we'll maintain proper relation here. I'll make it here side view and I'll adjust this properly by dragging manually near to that. Just I will rotate and I'll manipulate this manually. Like this we want relation between these two. Now again it will be moving up and down direction. So to lock that, so just I'll go here with mate. I'll apply mate between this central axis to this central axis. We need here distance. So let me make it here distance here. How much it is there? You can give here, as you can see 396 we are getting here. So let me make it here 395. Now let's say okay here with 395. Just I'll click on okay, then I'll say it okay here. Now if this rotates, along with that this also should rotate. For that we need to apply here gear mate. So to apply that gear mate we need profiles here. For that let me open here gear. So here you can see tooth cut will be there. I'll show this sketch. So usually sketches will be hidden. I'll show the tooth cut. So once, like if I show for one gear, automatically for one more gear also it will be shown. Why? Because we have taken from standards. Now we will apply relation between these two. For that, I'll go for mate. We need here mechanical mates. Here gear mate we want with between, we need this gear and this one. In between these two we need here gear mate. So here we are able to adjust ratio also. Like if I move here one rotation, this also will get, like it will rotate one rotation only. Like that we can make it in reverse direction also. So I don't want to change anything here. Just I'll say okay. Now just I'll make it here proper view. Now just I'll try to rotate this. As you can see, if I rotate a single gear, automatically this opposite driven gear also going to rotate like this. So let me hide the sketches. I'll open this. Whatever the sketch we have shown, I will hide that. Now just if I rotate here properly, that also it will get rotation. So instead of rotating this manually, already we know that we can use here motion study. I'll go for motion study, and in motors we'll be having here two type of motors, rotary motor and linear motor. We need rotation here. I'll go with rotary motor for this phase. It should rotate like this. How much speed we want, that also we are able to manage here. Let's say okay. Then go here with this motion study properties, increase frame rate. So frames per second is nothing but, like if you want to observe that motion clearly, we need to increase here frames per second more. So let me give here some 60 or 80 like that. Let's say okay, and let me click on here calculate. Automatically it will get rotated. So let's calculate that. Then already we know different type of options will be there here, loop modes or normal mode or reciprocate mode. I need continuous rotation in one direction. I'll make it loop mode and I'll make it here play from start. So we are able to adjust the speed also. Let me make it slow for better understanding. You can see here. If one driver gear is rotating, automatically along with reference to that, driven gear also will get rotated. So like this we can make it here simple motion studies and animation videos in SolidWorks. It is quite simple in SolidWorks. So let me go back to here model. So I hope you have understood about this gear mate. Then again I'll go for mate. Under this mechanical mates, next option we are having here rack pinion. So rack pinion already we have studied in our engineering, and already we know as a mechanical engineer, and already like as a mechanical engineer we know like what are the gears, rack and pinions, which type of joints and all we know. So now let's make it here with the rack and pinion. I'll go for assembly design. Same here also, rack and gear is already available in standards. No need to create our parts like by our own. Directly we can go here with the design library. Under that, same power transmission ISO standards gears. I'll take here rack for spur rectangular. Just drag and drop. Then here also we are able to adjust how much we want. So module, let's select some 20 or 30. Let me select here 20 module. Then pressure angle, I am not touching anything here. Then this face width we are able to adjust. Let me give some 20. Then total length, how much we want. Length I'll make it some 1000 like this. Then teeth, how much. Total overall length of this 1000 we want, or how much we want, we are able to modify here how many teeth we want to show. So this is enough, I think. This much is enough for us for this rack. So just I'll say okay. We don't want one more, only one enough. So just you can close here, or else you can use escape in keyboard. So this is rack. This is also got fixed, but it should be able to move like this. So for that, let me make here float. Now freely it will be able to move. To make this proper alignment, why? Because this rack should move only in linear direction. So only in this direction it should move. For that, I'll go for mate. I'll make relation between this bottom face to this top face. Let's say okay. Then again it will be able to move this front and back. Again for that purpose, I'll select this side face. For that, I'll make relation with reference to front face. Okay. Now this will be able to move only in this left and right direction. It won't move up and down or front and back like this. Then for rack, we need here pinion, right? So pinion is nothing but gear only here. We can take again spur gear. So let me reduce this size. Module I'll reduce. Half I will take like this. Then teeth also we will reduce. Teeth, let's take some 10 or 15. Let me make here with 15 or 10. Why? Because this should match to this. So let me say take some. I think this is also bigger. Let me take module 20. Then same width and all we can manipulate here. Let me make it some 30. Hub style all already we know. So I think this is enough for us. So just I'll say okay. Here also gear we need only one. I'll use escape. Then we'll make relation between this face to this face. It should be parallel to that properly like this. Then by using Ctrl+1, I'll make it front view and I will align this properly wherever we want like this. Let me align like this. Then next to that, this side also it is not aligning properly. We'll go for mate. So here we have given in reverse direction this coincident mate between this to this we given. Let me edit that. We will make it here opposite. Then it will align properly like this. Then Ctrl+1. Now here this distance we need. Why? Because it will be able to move in up and down direction. To lock that, for locking that, let me show here axis. Then made between this axis to this bottom face, I'll make here a distance. So how much we have adjusted, directly it will take that much. Let me make it round off here 200. Let's say okay. Like this. Then here you can see if I move this, only it is moving like this. But what we need means it should align with this teeth and it should move along with that. So for that, we'll make it here rack and pinion mate. So again, we'll go back to here mechanical mates. Here rack and pinion we want. Now rack we need to select, pinion we need to select. For that, let me open rack. Same here also. Tooth cut will be there. We need to show that. Then again for spur gear also tooth cut will be there. We need to show that. Now we need here relation between this line to this line. And let's say okay. Same here also, same direction or opposite direction we are able to adjust. Now just let me hide that sketches. For rack, this tooth cut sketch I need to hide. For spur gear also tooth cut sketch I need to hide. Now just if I drag this, you can see along with that spur, that gear also will be rotating. Let me make it front view for better visualization. Just I am able to move this. Along with that, gear also will get rotation like this. Same here also, minimum maximum dimensions we can give and we can make it. Again, if I rotate this, along with that, this gear will travel. So this is a spur gear mechanism like this. So by using spur gear mechanism, we are able to convert linear motion into rotary motion or rotary motion into linear motion like this. So I hope you have understood about this spur gear. Then next to that, under mechanical mates, we are having here screw mate. So screw mate is nothing but, let's say for example, we are having bolt and nut assembly. So directly I'll show you with standards itself. Just I'll go here again with assembly design. Let me cancel that. Why? Because standards are available in design library. We need here ISO standards, bolts and screws. I'll take here hexagonal bolt. Anyone we can take according to our requirement. So which type we want, we are able to select. You can see different type of bolts will be available. Let me take it here normal one. Then size I'll make it here some M10. This length we are able to adjust here. Length I'll make it some 100, or else I will reduce this a little, 70. Okay. So for this bolt we need nut gate. So again we'll go for design library, come back, come back. Next we are having here nuts. I'll open that. In nuts also different type of nuts are available. I'll take it normal standards. So here with washers we'll be having different type of washer with the self-logging nuts also will be available. So let me drag this any one. I'll take one. Size we wanted here M10. Let's say okay. Now this to this we need relation. So for that, see here with the washer also it is there. So what we wanted here means if I rotate this, it should rotate along with this shaft. So for that I'll go here with mate. Let me make here this to this concentric first. Then this face to this face coincidence. So if we make coincidence, it will attach here. It won't move. So just I'll keep it for positioning. I'll drag it. I'll keep it somewhere here like this. Now go for mate. Mechanical mates. Screw mate. We need to select here screw mate between this to this. And let's say now if I rotate here, you can see it will work like a teeth rotation. So manually, like if we fix bolt and nut, how it will go, like that it will go. So if you want with clear, you can open this with standards, and here teeth cut will be hidden. So just let me show that. I think we are not able to show here. So let me check. For this nut, hexagonal bolt and nut, teeth cut. No, we are not able to specify here. Usually we can see the teeth cut. So just you can see if I rotate here, if teeth is there, how it will roll on that, same like that only it will show. So instead of rotating like this manually, we can apply here motion study, motor, rotary motion for this one. We need in reverse direction. Okay. Just I'll go here and I'll adjust this frames per second and I'll make it calculate. Automatically it will go and it will rotate, it will lock and it will open if you want. So if you want more length up to here, just we need to increase this timer like this. How much distance we want, that much we need to increase here. Again, if you want reverse back, we can make it here reciprocate mode. Automatically it will get tighten and it will get loose. Like this it will get tight, then again it will become loose. So like that we can use, and we can show this animation also by using this motion study. So this is about screw mate. So I hope you have understood about this screw mate. Now let's see this last mechanical mate. So just I'll go here with new assembly design. I'll close this. I don't want anything. So last mate under mechanical mates we will be having here universal. So universal is nothing but, let's say for example we are having one component here and one more component here. So this is like universal coupling. So this is a driven one, assume that, and this is a driven one. So if we will make relation between this to this like this. Once if it get rotation, automatically along with this also will get rotation. It means we are able to transfer rotary motion from one shaft to another shaft by using this universal coupling. So that we will see here. So for this also already I have created one part. So let me go back here. Universal, just a single part I have created. For example, this is a part. Let me make it like this. Now, this will be fixed. We need here motion. It should rotate in rotary motion. For that, let me make it here float. It will be able to move freely now. Then, to make relation, we need here temporary axis. I'll make relation with reference to this axis to this origin point. Properly, it will align to that. Let's say OK. Then to log this front and back motion like in this direction, I'll use here right plane to this face. Let's okay. Now this part it won't move anywhere, but it will be able to rotate like this. Let me make it isometric. Now same part we need one more here. For that just we can hold control, drag this like this. Then by using this rotate component, just I'll rotate like this. We need like this relation. Okay, we'll make relation between this axis to axis. Okay, then we will make relation between this face to this face. So directly if we apply parallelism, if I rotate this, automatically this also will get rotated. Same similar to that, here also we can apply this mechanical mate. We can go here with universal joint. So we need to apply between this to this. So just I'll say okay. If we rotate one, automatically one more also will get rotated like this. So just you can see like this. Same if we apply here motion study, again rotary motor. If I rotate this, let me adjust frames per second. I'll make it some 80. Okay. Then if I make calculate, automatically one more also will get rotated. Like this is the driving one. Along with that, this also will get driven. So this is about mechanical mates. I hope you have understood about this all types of mates and especially about this mechanical mates clearly. So if you really like the video, please like the video and please share to your friends to whom it will be useful. And maximum people simply they are watching and they are leaving. Please subscribe to my channel and please support me to do more videos and to do in different way of teaching and let me improve my teaching skills also with your suggestions in comment box. Thank you so much.